Hi, today we're going to talk about one-dimensional kinematics. Let's start by talking about distance. Distance is the total length traveled in an object's path of motion. The distance traveled from an object on this path from A to B to C would be 8 meters. Displacement, on the other hand, is the total distance from the object's starting point to the object's ending point. In this case, the magnitude of the object's displacement will be 4 meters. Notice how I use the word magnitude. Magnitude refers to the length of a vector. Since displacement is a measurement that includes direction, we would use signs to determine whether the object is moving in a positive or negative direction. The magnitude is just the absolute value of the displacement. This is very important, since in kinematics equations we will need to use the respective signs. So these are the four main kinematics equations. So let's try a couple of word problems. So for this one here, let's list all the known variables first. And then let's try to find the equation where we can input the given variables, which are initial velocity, acceleration, and time, and find the needed variable, which is displacement. In this case, it would be the third equation. So we plug in all the variables and solve for x. So we're going to write delta x equals 12 times 6 plus 0.5 times negative 1.6 times 6 squared, which is then simplified to 72 minus 28.8, and we get a final answer of 43.2 meters. Let's try this one. A car is traveling 20 meters per second when the driver sees a child standing on the road. She takes 0.8 seconds to react, then steps on the brakes and slows at 7 meters per second squared. How far does the car go before it stops? We're going to do the same thing as last time, where we list all the given variables, and then find the equation we can plug these into. In this case, it is implied that the final velocity is 0, since we will take the velocity of the car when it stopped as final. The fourth equation seems to be the best one for this. So we plug in 0 equals 20 squared plus 2 times negative 7x and solve for x. We will set the acceleration as negative since it is accelerating the opposite direction of motion. We get x equals 28.57 meters. However, this is not our final answer. At the beginning of the question, it says she takes 0.8 seconds to react. This means that she's traveling at 20 meters per second for 0.8 seconds, in addition to this first distance. So we do some basic dimensional analysis and convert 20 meters per second for 0.8 seconds to 16 meters and add that to our previous answer. Our final answer is 44.57 meters.